Hello, Dragon Caravan. Let's talk about volume and displacement, shall we? As we know, volume is a way of measuring something. But what we didn't talk about were other ways of measuring things. Let's talk about the basics of measuring. We'll start with length. Everybody knows what length is, right? And then from length, we also can go to area. Now, length and area are related, as is volume. But let's dig in and take a look at each one of these things. So first of all, let's start with length. As you know, length is what we say one dimension. It's how long is something, how tall is something, how deep, how wide, but it's always one number. I am 6 feet tall. That lake is 20 feet deep. This box is 5 inches long. So we always measure in some kind of units. And those units can be feet or inches or centimeters, meters, miles, kilometers. But it's always measuring the length. Okay, one dimension or 1D. When we talk about area, we move to 2D, the second dimension. To keep it organized, we can label these with letters. So we'll always say that if I hold my arms out side to side, right and left, that will be X. That's the X-axis. If I point up to the sky or down to the ground, that's the Y-axis. And together, when we use these two values, we can calculate the area. How much space does that take up? As you can see here, we have an X dimension and a Y dimension. If we then finish that off into a nice rectangular or square space, that's the area. 2 dimensions. And guess what? If you take this number, multiply it times that number, that gives you the area. And we also call that squared. So for instance, we were sitting on a carpet, actually we were sitting at a table yesterday, and the table was 4 feet wide, 4 feet on X, by 6 feet long. And we know that 6 times 4 is 24. So we would say that the area of the table was 24 square feet. And it's square because that makes a flat square. All right. So length, 1 dimension. Area, 2 dimensions. How many dimensions do you think are in volume? Well, let's take a look. So here's our area, 2 dimensions. Aha! We have a 3rd dimension. 3D. And we're going to call this axis the Z-axis. So this is the one that's coming out of the screen at us and going back into the screen away from us. Okay, so why are some movies called 3D? When you watch a regular movie, you just see it projected on a flat screen, right? You see a Y-axis that goes up towards the ceiling. You see an X-axis that goes from one wall to the other wall. But if you put on the funny glasses, all of a sudden things pop out at you or they seem to go back into the screen. And that's the 3rd dimension, 3D. And that's the Z-axis. So when we're talking about calculating volume, that will be X times Y times Z. And that will give us the volume. And unlike area, which is the square, this creates a cube. And so we say it's cubic feet. So let's just close that up. So if we had a little juice box, we want to know how much juice will fit in our little box. Well, we just multiply X times Y times Z, and that might be in cubic inches or cubic centimeters. Just depends on what you measured it. If you measured it in centimeters, that would be cubic centimeters. If you measured it in inches, it would be cubic inches. So that's the volume. So we go from length is 1 dimension, area is 2 dimensions, and then volume is 3 dimensions. Pretty cool. All right. So when I say, what is a cubic foot? Is it a foot in a cube? No. Well, yes, it is kind of, but not that kind of foot. It's actually the inches, 12 inches foot. So, and this is how we could write it. The foot cubed, because it's 3 dimensions, right? If it was in inches, you'd say 12 inches cubed. So when you see the number raised up above like that, we would say cubed. If it was a 2, that would be squared. So this is 12 inches cubed. And that's what we talk about with a cubic foot. So here's our cubed foot. And we know it's a cubed foot because we have 12 inches here, 12 inches here, 12 inches there. Another way to say 12 inches is to say 1 foot. So 1 foot on Y, 1 foot on X, 1 foot on Z. That's a cubic foot. Now, why is that a cubic foot? Well, how would we calculate that? If we're talking about feet, we need to multiply the x-axis times the z-axis times the y-axis, right? So 1 times 1 times 1. What's 1 times 1? Is 1. And what's 1 times 1? It's 1. So that's 1 cubic foot. Now, what if these are not exactly 1 foot? Let's take a look here. Here we have 1 foot on X, 1 foot on Z, and 2 feet on Y. We stretched it up. So what's the volume here? Well, again, the volume is X times Y times Z, so let's calculate it. 2 times 1 is, that's right, 2. And 2 times 1 again is, you guessed it, still 2. And so the volume of this shape is 2 cubic feet. Now let's get a little bit more complicated. Let's say our cube is 3 feet on each side, okay? We just grew it up there a little bit. 3 feet by 3 feet by 3 feet, 3 on Y, 3 on X, 3 on Z. So how do we calculate it? Once again, we know the calculation is X times Y times Z. So this math's a little harder, but I'll bet you can do it. The volume is 3 times 3. I'll give you a second. Yep, 9. 3 times 3 is 9. And then times 3 again. And 9 times 3, I don't have enough toes. There we go, 27. 3 times 3 is 9. 9 times 3 is 27. So the volume of our 3 foot by 3 foot by 3 foot cube is 27 cubic feet. Now, I find this sort of interesting because if it's 1 on each side, it's 1 cubic feet. And if it's 3 on each side, it goes to 27. Kind of would think it would be 3 cubic feet, but it's not. And let's see why, because we're growing on the cube. So let's take a look. Here we have a 1 cubic foot. Here we have 1 cubic foot, but we're going to grow this to 3 cubic feet. So, or rather 3 foot on each side, which is going to be that 27 cubic feet. So here we go. We grow it out 3 cubes on the X. Now let's go 3 cubes on the Y. And now let's add 3 on the Z. See how those all fit in there? So you can see on any dimension, X, Y, or Z, it's only 3 times larger. So we measure it on this axis. It's only 3 times longer. On this axis, it's only 3 times longer. And on the Y axis, it's only 3 times taller. But if we look at all the cubes inside, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. It takes 27 cubic feet to make this shape that is 3 feet by 3 feet by 3 feet. And that's the volume, 27 cubic feet. Pretty cool. So what does that mean for our boat? Well, now we have the tools to calculate it. Although, this shape over here is not a cube, right? It's kind of a triangular shape. That might be hard to calculate. So tell you what, let's ignore it. We're just going to skip that altogether. And imagine that our boat is a perfect rectangular cube that goes 6 feet here, 1 foot up, and 2 feet back. So 6 by 1 by 2. So how on earth will we calculate the volume? Well, you know that. It's X times Y times Z. X times Y times Z. 6 times 1. What's 6 one time? That's right, it's 6. And what's 6 times 2? That's right, it's 12. So we have 12 cubic feet. Cool. That's the volume of our boat. Not considering this little part up here, but again, just giving us a rough number. It's about 12 cubic feet here. Okay, so what does that mean then for how much water our boat will displace? We know the boat will displace 12 cubic feet at least. So what does that mean for how many people we can put in the boat? Well, what we would need to know is how much does 12 cubic feet of water weigh? Well, let's think about that. First of all, let's take a look at a practical example. This man here weighs 188 pounds, including his stylish suit. Here is 1 cubic foot of water. Now, if we just stack it up and say, let's get roughly this stack of water that looks about his size, how many of these cubic feet of water do you think would be required to weigh the same as him? 1, 2, 3, 4, 5, 6. 6 makes it as tall. Well, let's go ahead and take a look here. 1, 2, 3, 4, 5, 6. Don't know. Let's do some math. 1 cubic foot of water equals 7.48 gallons. Basically 7.5 gallons. And we saw that when we poured gallons of water into our cubic foot. Now you may remember we filled ours with 6 gallons, but ours was actually a little bit short on the y-axis. So if we had a full 1 foot by 1 foot by 1 foot, it would actually be 7.5 gallons. And the weight of 1 cubic foot of water is 62.4 pounds. Some of our Dragon Caravan members weigh less than a cubic foot of water. And we saw that when we tried to balance them on the teeter-totter, didn't we? So, isn't that funny? You can't sit in this 1 foot by 1 foot by 1 foot cubic space, but it actually weighs more than you, or as much for some of you. All right, so that gets us back to 188 pounds equals basically 3 cubic feet of water. So you can see here's our guy, and if we put him on a scale or on a balance beam, this is the amount of water that would equal his weight. And that means that 3 cubic feet in the boat will displace enough water to keep him afloat. Now, you don't want to make it exactly the amount of displacement because then your boat would be right on the edge, right? So we have to figure out how much we actually want to displace. But we know our boat can displace up to 12 cubic feet of water. The man equals 3 cubic feet of water. So the question is, will he float? If we put that man in our boat, would he float? Well, let's see, shall we? Are you ready? 3, 2, 1, float, man. Let's see. Okay, yes, he floats. And you can see he floats pretty high up on the water because when he pushes down, he only needs to displace 3 cubic feet of water, not the full 12. All right, so here is the 12 cubic feet of water that our boat can displace. And if we multiply 12 times 62.4, we get 748.8 pounds. That's a lot of water. But remember, we don't want to load up the boat with 748 pounds, do we? Is what will happen. How about the hippo? Do you think our friendly hippo will float or sink? Are you ready? Let's find out. 3, 2, 1. Oh, no, hippo. Hippo weighs how much? About 3,000 pounds. Yeah. So do not bring your hippos when we go to sail our boat. Important rule. All right. So again, we know that roughly 750 pounds is how much water we're going to displace. It'll be a little more than that because we have this cavity up here, but just being safe. So where do we want the water line? If we put 750 pounds in here, the water line's going to go right up to the edge, isn't it? And now what happens if someone has to scratch an itch and they lean to one side and the boat tips a little bit? All the water's going to go in. Do you remember the term where the water line meets? That's called the water line, of course. And then above that is the board that's free. What do we call that on the boat? The part of the boat above the water? That's right, the freeboard. So we have to determine how much freeboard we want to be safe. So if we take our water line here, 750 pounds is going to put us right up to the edge. That's a little scary if you ask me. No, we don't want to do a full 750 pounds. We want, maybe half to 2/3 of the boat above the water. So we have to keep the weight of the boat below half or a third of 750 pounds. So there's a little math you can do to figure that out. What's half of 750 pounds? And that would tell us how much weight we can put into our boat. Okay. Don't forget, when we're figuring that out, our boat actually weighs something as well. So we need to think about how many people can ride safely in our boat. And that's something that you can maybe think about and come back next week and we'll talk more about that. But again, we want this to be at about half or less. So some basic math you can do there. And don't forget, there are some other considerations. If we go to half the boat at the water line, if all of the people, should we put everybody in the back? Probably not. Should we put everybody to one side? Probably not. We need to evenly distribute. So that means if I'm going to ride in the boat and I weigh about 200 pounds, if I sit back here and Mari sits over here, we're going to tip, aren't we? So we have to make sure that we distribute ourselves wisely. And then I want you to think about what you know about boats so far and how can we make our boat even more stable so that when we're getting in and out of the boat, we don't tip over, we don't tip it enough to pour water into the boat. That would be bad. These are all important things to consider. Okay, so hopefully now you've had some time to think about volume, how to calculate volume, and you know a little bit more about area and length. It's all pretty simple stuff. Kind of builds up on itself. 1 dimensions, 2 dimensions, 3 dimensions, x and y, x, y, and z. So simple math, some basic multiplication. And that will tell us the volume of our boat. And that'll keep us dry, I hope. Okay. And then another thing. If we can't get everybody into one boat, how can we all get across the lake? Well, there's something for you to think about. Okay. Until next time, we'll see you soon. Cheers.